Alright, so this video is going to be part 1 of arc length problems with polar, okay? So we have our question up on the board. What is the arc length of r equals theta from 0 to 1? We know our equation, right? That's the integral from a to b of the square root of r squared plus dr d theta squared d theta. So let's start plugging in here. We have our bounds. That's the integral from 0 to 1. And, well, we have r squared, that's going to be theta squared. And then we have dr d theta squared, right? So dr d theta first, well, that's just going to be 1. And when we square that, and we get 1. Okay? So actually, we're just going to end up with a 1 here. Now, this integral looks familiar, right? And that's because it's going to be just a trig substitution. Okay? So we can do that theta equals tangent theta, we'll have to do a different letter this time. I guess we'll do like beta or something like that. And then we have that d theta will equal secant squared of beta d beta. Okay, so now we can just plug that in. We get the integral. We don't know what our new bounds are yet. We're going to get in the square root tangent squared of beta plus 1. And then on the outside, we're just going to get a secant squared of beta d beta. All right, well, what's going to be our bounds? Well, if we have a 0 here, okay, well, that means that there must have been a 0 here. Tangent of 0 is 0. So we'll have a 0 as our lower bound. Now, tangent of what is going to give us 1? That's going to be pi over 4. All right, so now we have our integral. We know that tangent squared plus 1, that's secant squared. Take the square root of that, that's secant. So we're going to end up with the integral from 0 to pi over 4 of secant cubed beta d beta. All right, now, okay, we end up with this secant squared or secant cubed integral, and it takes a long time to do this. You have to do integration by parts and all that good stuff. But honestly, if you can memorize this, because it's very prevalent, and I haven't told you to memorize it before in past videos because I forgot how prevalent it is. Like, it just, you get a secant cubed all the time in calculus too. So if you can remember that integral, it'll help you a lot. You end up with 1/2 secant x tangent x plus the natural log of secant x plus tangent x. And this is going to be all evaluated from 0 to pi over 4. All right, when you do your evaluation, well, first off, is that 0 going to kill everything off? Well, it'll make this piece 0 right here. And, well, it'll make this 0, natural log of secant of 0. Well, secant of 0, that's 1 over cosine of 0, which is 1. So you're going to get a natural log of 1. That's 0. So 0 does actually kill everything off here. So we only need to worry about pi over 4. Now, if we plug in pi over 4, we get 1/2 times, this will be 1 over cosine of pi over 4 times tangent of pi over 4. And then this will be plus the natural log of 1 over cosine of pi over 4 times tangent of pi, or no, plus tangent of pi over 4. All right. Now, by the way, if you're not seeing it, I'm writing secant as 1 over cosine just because it'll make it a little bit easier for us. All right. Doing our little evaluation here, or just simplifying this, I guess. 1 over cosine of pi over 4. Well, cosine of pi over 4, that's rad 2 over 2. You flip that up into the numerator, and you're just going to get rad 2. Okay, so you'll get 1/2 times rad 2 Tangent of pi over 4, that's just 1. We don't need to worry about that. And on the inside, also, you'll have a plus natural log of 1 over cosine of pi over 4. Again, we said that is rad 2, and then we know tangent of pi over 4 is 1. Alright, now, we also know that we don't need the absolute value here, because these are positive, so the absolute value is redundant. 1/2 times rad 2 plus natural log of rad 2 plus 1. And that, right there, is going to be your answer. Alright, so, yeah, nothing too difficult. I mean, if you know what that secant cubed integral already is, then it cuts out a lot of work for you. But other than that, it's kind of just plugging in, recognizing what you get for, your integrand, how are you going to be able to integrate that, and then that's pretty much it. Alright, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for polar arc length, and the next video in the series. See you soon.